In this video, we'll learn about order statistics. So suppose y1 through yn are IID continuous random variables with the same PDF and CDF. And let's say we sort the yi's such that the min is on the left, the max is on the right. The min is also known as y parentheses 1, the max is y parentheses n, and then everything else is in between. Notice that we can't actually have equality because with continuous random variables, the probability that any two are equal is 0. So we don't have to worry about having a less than or equal to sign. Notice that each yi is a random variable as well. And we call y parentheses I the ith order statistic, meaning the ith smallest in a sample of size n. We're interested in finding the distribution of each order statistic and properties such as the expectation of variance. So as long as we find the PDF or CDF, we would be able to calculate everything we wanted to. So why are order statistics important? Well, usually we actually take the min or the max of a bunch of random variables and then do some computation with it, or the median. And it would be great if we had a formula for the PDF or CDF of a min or max in general. So let's start with an example to find the distribution of y max, the largest order statistic. So we'll start with the CDF, which is the probability that the max is less than y. And the max is less than y if and only if every single yi is less than or equal to y. And since the random variables are independent, we can actually write this as the product of the probability that each yi is less than or equal to y. And because they're identically distributed, they have the same CDF, which is capital F sub y of y, and then we just have the same thing n times, so we just have it to the nth power. And so now we just differentiate the CDF to find the PDF. Notice this is of the form something to the n, and so the derivative will be n times that something to the n minus 1, and then also times the derivative of that because of the chain rule, and the derivative of the CDF happens to be the PDF. Now we'll use a very informal argument to find the density of a general order statistic. So y sub parentheses I, we just did it for the maximum one, which is y parentheses n. So one of the values needs to be exactly y. I minus one of them need to be smaller than y, and this happens with probability each f capital Y, which is the probability y is less than or equal to y. The other n minus I need to be greater than y, and this happens with probability 1 minus capital Fy of y. And so now there's three distinct types of objects. One that is exactly y, I minus 1 which are less than y, and n minus I which are greater. So again, we're trying to find the density of the ith order statistic, the ith smallest one. And so we're kind of finding the probability that yi is near y. So we need one of them to be y out of the n. Then we need I minus 1 to be smaller and n minus I to be greater. So we're going to end up with some kind of coefficient like this, which looks like a multinomial almost. And then we have to actually stick in this multinomial coefficient because for the ith smallest to be y, we can actually choose any of the n to be equal to that, any I minus 1 to be smaller, and any n minus I to be larger. And so actually if you plug in n here for I, you can verify that the PDF that we get is actually the same as the one we just derived earlier. Now let's do an example with the uniform. If y1 through yn are IID continuous uniform 0, 1, where do we expect the points to end up? This is very informal, but for n equals 1, I would expect it to be at 1/2. For n equals 2, I would expect them at 1/3 and 2/3. If n was 4, I would expect them at 1/5, 2/5, 3/5, and 4/5, because they're uniformly spaced along the interval. So we can actually calculate the expected value of the ith order statistic. So we use the density function that we derived earlier for the ith order statistic, and we know the CDF and PDF of a uniform 0, 1, so we can plug all that in, do all the math, and you get that the expected value of the ith smallest is I over n plus 1. So let's look at a picture. So what it says is that the expected value of the minimum, or the expected value of y parentheses 1, is just 1 over 4 plus 1, or 1/5. The expected value of the largest is expected value of y sub 4, which is 4 over 4 plus 1, or 4/5. And also the interior ones at 2/5 and 3/5. So this is what order statistics are. And here's a summary of everything we just talked about, including the general PDF of the ith order statistic.